So let's plot a couple of these to see what these relationships look like in a scatter plot. So let's start with the significant one that we got from the natural factors. So we go graphs and legacy dialogues, and then choose scatter and or dot plots. Just choose a simple scatter and go define. And if we pop our y-axis is mean observed temperature, and we'll put solar in as our x-axis, and go OK. So you can see here that what a scatter plot does is plot each point observed temperature against its value of solar, whatever they're measuring. And you can see that when this correlation comes out at 0.45, you can see that if we wanted to draw a straight line through this relationship, we could do that. But the reason the correlation is only 0.45 is that there's actually quite a lot of distance. There's quite a lot of error in this relationship. There's quite a lot of distance between each of these points and this imaginary line that the model is drawing. Right? So you can see that increases in whatever they measure in terms of solar activity are the highest values of solar activity also tend to have the highest values of temperature in terms of years. So years that have very high solar activity also tend to have very high temperature readings. Okay, so let's try a couple of the human related factors. So the biggest one we saw was greenhouse gases, correlation of 0.92. So if we leave observed temperature in the top and add greenhouse gases and have it plot that, you can see that this relationship looks quite different, right? So the reason that this one is a correlation of 0.92 and this one is only a correlation of 0.4 something is that when we plot a straight line through this data, all of the points cluster really closely to that line. There's not a lot of error. Years that have very high readings of greenhouse gases are those years that have very high temperature increases, and there's not a lot of error in this relationship. All the points cluster really nicely around that line. Okay, let's try a negative one in terms of graphing a scatter plot. So choose graphs and legacy dialogues, go all the way down the bottom to scatter, and then a simple scatter. And let's put in aerosol use. So aerosols, the world kind of got rid of harmful aerosol propellants back in the 80s. And so aerosol use has kind of declined over the last 20 years. And what this is showing is that aerosol use, the highest values of aerosol use are actually associated with the lowest values of temperature. And the lowest values of aerosol use, the years that have low aerosol use, tend to have high temperature. Now that's not, I don't know that that's telling us. So this is one of those situations where you have to be careful about interpreting correlations as causing anything, right? So we can't necessarily say that our getting rid of aerosols has made the world warm, because there is, in all likelihood, a third variable that is responsible. So we can, if we look, I'm approaching my free recording limit. That's not so good. It is likely that greenhouse gases are also associated with aerosols. If you go back and look at the correlation, and that is probably what's driving